All right, let's go. Yeah. Radical equations. So now we want to solve what we call radical equations. So what is the difference between, a radical expression and a radical equation? The equal sign. This is a statement of equality. When I say solve an equation, I want to know what value, in this case of x, is going to make that statement true. If it's an expression, here's an expression. There is no statement. There's no equal sign. I can't solve it. I don't care if there's an x in there or not. There's nothing to solve here. You just simplify, you evaluate, you rewrite. But if you have an equal sign, now you have to solve it. Now you have something that you're going to have to figure out what number goes into that x, into that variable that's going to make that statement true. Otherwise, if there's nothing that fits there, that statement is not true. All right, well, let's see. Now I have a radical equation. So an equation with an equal sign, and radical because I have radical expressions. So the first thing is to figure out the index, right? So what index do you have? I'm going to say, what's a word? Pay attention to the index. Once you determine that it's a square root, a cubed root, or whatever, you want to isolate the radical expression portion. So get it on the left-hand side, which in this case, it's already isolated. I have the radical expression on the left and just the constant on the right. You're going to raise both sides of your equation by the index of the radical. So in this case, it's a square root. Everything is going to be squared. Whatever I do to one side of an equation, I have to do to the other to maintain balance, right? It's an equation, a statement of equality. This is equal to this. So if I do something to this side, oh, it's unbalanced. I have to do the same thing to the other side to keep it equal. And why do I choose, squared? If I take a square root of something and I square it, it cancels the radical and leaves me with just the stuff underneath. It gets rid of it. So on the left, I have an x minus 7. And on the right, 3 squared is 9. And it becomes a beautiful, lovely equation, which is very simple to solve. Add 7 to both sides. And then x is equal to 16. Now, this is my solution if. Always check your solutions. Now, you could write it out and check it, or you can visually check it. I'll write out the first one. You could look at it and determine that it'll be okay, but you replace x with the value that you claim that it is, in this case, 16, and see if you get an equal statement. You'll see what happens. I'll do an example in the next video where you might get a situation where you solve it, you get a solution, you plug it in and it doesn't work. That happens sometimes with radical equations. But in this case, this works, boom, it's done. So this is my solution. No problem with that solution. So I solved it, right? Raise both sides by the index, and then I'm going to say check your solution. Always, if it's a radical equation, check your solution. You don't have to write out the check. You could visually check it, but whatever the heck makes you comfortable. All right, let's do another one. This one's a little bit uglier than the last one, right? This one, if you notice, it still is a square root. So I'm going to use an exponent of 2, but, I have the radical here. This is not under the radical sign, okay? There's a reason that the radical sign ends here. The -1 is not included under the radical sign. So in this example, my radical expression is not isolated. I need to isolate it. I need to have it alone by itself on the left-hand side. So in this case, I have to add 1 to both sides to get this 5x plus 11 under the radical by itself. Okay, isolate the radical expression first, and then determine how you're going to raise both sides. In this case, it's an index of 2, so I'm going to square both sides, which is nice because it cancels the radical. So I'm left with 5x plus 11, but if you notice on the right, I have x plus 1 squared, which is an x plus 1 times x plus 1, and that has to be multiplied out. So that's a little bit more complicated than if I just have a 3 squared. Now I actually have to multiply this out. Now, some of you know the perfect square trinomial pattern. So you can go straight from here to x squared plus 2x plus 1. Some of you that don't know that pattern, you need to review it. But you'd have to write this out on the side and then pull it back into your problem. You'd have to FOIL this here, x squared plus 1x plus 1x plus 1, and then simplify, and then pull it back into your problem. Now, the moment I see an x squared in an equation, I know automatically quadratic. When I think quadratic, I'm like, all right, am I going to factor it? Am I going to use the quadratic formula? This is where my head is going, just based on the fact that x squared appeared. But when I have a quadratic equation, I have to set it equal to 0. So I want to bring this over and this over. And the reason I'm bringing it that way is because I would rather maintain the positive on the x squared and not have it bring over here and make it negative. So let me show you. I'm going to get an x squared plus a 2x minus 5x minus 3x plus a 1 minus 11 minus 10. And that's 0 equal to that. So equals 0. Whenever you have a quadratic equation, you want to set it equal to 0 because you're looking for that 0 product property to happen, which means you have to factor it. And if it can't be factored, then you have to go into the quadratic formula. This one looks like it can be factored. An x and an x. Two numbers are multiplied to give me 10, 5 and a 2. And I want this negative and this positive because I want a negative 3. So my outer is going to give me 2x and a negative 5x, which will give me that negative 3x. So this is factorable. And then we set each of these factors equal to 0. And then solve for x. So plus 5, so x is 5. Subtract 2, x is negative 2. I'm not done. Check your solutions before you claim that they are solutions. And this one I might show again. Check your solutions. Check it. That's okay. The first one, let's start when x is 5. And then here I'll do when x is negative 2. You have a choice. You could go back to the original and plug it in here, or you could technically go to this one where you isolated the square root, which I probably will. So when x is 5, I have 5 times 5 plus 11 on the left equal to 5 plus 1 on the right. This looks like it might work. 25 plus 11 is 36, and that works. So this is my solution. That works. Let's see if negative 2 works. 5 times negative 2 plus 11 on the left is equal to negative 2 plus 1 on the right. I know this is not going to work. I can see it already. I'll show you why. Negative 10 plus 11 under the square root is positive 1. Now the square root of 1 is 1. But on the right-hand side, I get negative 2 plus 1, which is negative 1. The square root of a number will never be a negative result. So this is what happens sometimes with these radical expressions, radical equations, I should say. Sometimes you get a situation where you plug it in and you do not get a true statement. This is not a true statement. A square root of a number will never be negative. And this sometimes happens with these type of equations. So this is not a solution. This is an extraneous solution. And the only solution is 5. Extraneous solution, you know, we talked about in previous videos, oops, where you actually solve a problem, you get to a solution, but when you plug it in, it doesn't work. It's called an extraneous solution. And if both of these worked, that's possible. If both of these didn't work, then there would be no solution to this equation. There would be no value of x such that this would be a true statement. So, you know, you get all different scenarios. Both of them work, one of them works, none of them works. I mean, it doesn't matter, you know.